Hello everyone. So in this video, we're going to look at example of unit vector normal. Alright, and we are going to explore that using the two different formulas, method 1 and method 2 that we saw earlier. So for unit vector normal from your lecture slide, okay, for example, if we are to find unit vector normal for z equals to 2 minus x minus y. Alright. So let's start with method 1. We're going to explore this with two different methods. So let's start with method 1, and method 1 would be the one where my n cap is equivalent to my gradient of f over modulus of gradient of f. Alright, so in this case, what we basically do is that if you want to use this formula, so see that gradient f basically means that you need to get your function, right? So your function has to be expressed to be equivalent to 0. In other words, if we are going to use this method, we need to express f in terms of putting everything onto one side. Alright, so in this case, say I move this to the left hand side, if I re-express it again, then it will give me x plus y plus z minus 2 equals to 0. Alright, so this is my function f. Alright, so let's start with the gradient of my f. If you still recall, how do I get the gradient of my f? It's basically my df over dxi, partial derivative of each, df over dy j plus df over dzk. Alright, so with the first term, if I just do this directly, I can do that as well. Alright, so if I just do this directly, my df over dx, which means partial derivative with respect to dx here, will give me what? It will give me 1, right? Actually, my df over dx I. And then for df over dy, same thing goes. I also get 1. G. What about z? Same thing goes. 1. Alright? So in this case, there goes my, don't forget my k. So basically, it's just I plus j plus k in this case. Yeah. So basically, once you have identified your f, do a partial derivative with respect to dx, dy, and dz. Now I want to find the modulus of my nabla f. Alright. And if you recall how I get my modulus, modulus basically is the magnitude, right? So basically, I'll get the square root of each coefficient here, which are being squared. So each coefficient squared, add those up, get the square root. That leaves me with cert3, or square root of 3. So in other words, therefore my n cap, my unit vector normal, will then just be I plus j plus k over square root of 3. Alright? So that's one way using method 1. So pretty easy, right? So let's explore method 2. For method 2, I'm just going to rewrite the expression earlier as what is given in the question. The equation goes like this, right? Just now we move everything to one side and make it equivalent to 0 so that becomes my f. That is for method 1. If we're looking at method 2, remember? So it really depends on which plane that you're looking at. So for example, if I want to express this, let's express this in terms of xy plane. So then my n cap becomes negative df over dx of I minus df over dy of j plus k. So remember the negative plus over square root of 1 plus df over dx square plus df over dy square. Alright? So, as usual, so now, of course, then, if we are going to decide to put this in terms of xy plane, then in this case, it just so happens that my f will then be my z, which is expressed in terms of 2 minus x minus y. A way for us to validate this will be to make sure that your expression, alright, for your f will only have the variable in terms of x and y, alright, because that means that your surface area actually is expressed in terms of being lying on xy plane. Similarly, if you want to look at xz plane, for example, then in this case, you will put y to be the subject. Then you will get 2 minus x minus z. And therefore, your x and z will also correspond accordingly with these first two terms here and the denominator here, as what being explained in the previous video. I'm not going to go through that, but we are going to look at xy example here. So say that we have already got 2 minus x minus y. All right, my f is 2 minus x minus y, and therefore I need to get my df over dx, df over dy. So my df over dx, again, partial derivative, I get negative 1, isn't it? Df over dy, I get a negative 1. Alright. So basically that's the only thing that we need to get. And therefore, my n cap will then be negative of negative 1i will give me a positive, right? So I'll just write this directly as I. And then negative of j will give me a positive. Again, I'll express this as plus j. And plus k as usual. Alright. Over, now 1 plus, this is negative 1 square. My df over dx, which is this term here. Df over dy, which is also negative 1. So negative 1 square. So again, you can see that this is I plus j plus k over square root of 3. Comparing this is method 2. And if I scroll up a little bit, see that this is method 1. See to that both arrive at the same answer. So again, for unit vector normal, there's not much indication as which one is easier, which one is not. Again, it really depends on you doing your exercise and which one you actually prefer or which one suits you more. So as long as you're clear with this, then just stick to one, or you can also just play around with the methods according to what you like. All right, good luck.